Okay, to graph secant and cosecant, we need to be able to graph sine and cosine. So if you're still not comfortable with those, you want to go back to those videos and make sure that you're solid on those, because these graphs are based on the sine and cosine graphs. So let's just take a look at a couple of basic graphs. So here's our cosine graph. Okay, so 0 to 2 pi right there. We see one cosine curve. I've got that dashed in because that's not actually part of our graph. We just use it to get the graph of secant. So remember, secant is 1 over cosine. So we're going to take all of these y values and we're going to do 1 over them. So for example, here we're at 1. 1 over 1 will be 1, so it's going to touch there. But here, where we have 0, our y value is 0, when we do 1 over that, 1 over 0 is undefined, we're going to get an asymptote. So at all of the zeros, we're going to get asymptotes. At 1, we'll get 1. At negative 1, we'll get 1, negative 1. And then as we get closer to 0, when we invert those, it'll get bigger. So as numbers get smaller, closer to 0, when you do the reciprocal, they're going to get bigger. So let's look at what happens. Okay, so here's the secant graph. All right, so let's double check with what we were expecting. At the zeros, we see we've got asymptotes here and here. At 1 and negative 1, we touch because the reciprocals match. And then as we get close to 0, when we flip it, when we do the reciprocal, we're going to go to infinity, positive and negative infinity. Okay, so there's our basic cosine graph. And then all we have to do is flip it. So every one of these little hills is going to flip and become one of these U-shaped things. Okay, so let's look at sine. So there's our sine graph, 0 to 2 pi. We should be familiar with that by now. 0 to 2 pi. And when we flip that, again, zeros are going to become asymptotes, and each of these little bumps is going to become a u when we invert those numbers. And there we see the cosecant graph. Okay, so very, very similar, again, because sine and cosine look very similar, just in different places. Okay, so there's sine and cosecant. Okay, so what if we want to do something else? Like, what if we want to do cosecant of 2x? Well, we do sine, we would graph sine of 2x. Okay, remember what that 2 does? That changes our period. So instead of having a period of 2 pi, our period is now pi. We see that right here. Okay, amplitude is still 1. There's no shift up or down or side to side. Okay, so there's our sine graph now, sine of 2x. And the same thing, when we want to do cosecant of 2x, anywhere that there's a 0, that's going to become an asymptote, and each one of these bumps is going to flip to become a U-shape part of the graph. So there's our cosecant of 2x. Okay, so the key for secant and cosecant is to draw the sine and cosine graph that goes with it, that we already know how to do, and then it's just a matter of flipping it. Zeros become asymptotes, and each of the bumps becomes a U-shape. Okay, so let's go ahead and graph one of these from the beginning, from scratch. We're going to look at how to do a secant graph. Remember, that's based on the cosine graph. So what we're actually going to graph to start with is 3 cosine, and I'm going to go ahead and factor this because we know that we need to have it factored, 2x minus pi over 2. Okay, so I'm actually going to graph the same thing but with the cosine graph instead first, and then we'll get the secant graph from that. So just like before, the 3 is going to be our amplitude. The 2 out front, that changes our period. So the period for cosine is usually 2 pi. So now our period is going to be 2 pi over 2, or pi. And then this pi over 2 means that we're going to shift to the right by pi over 2. Okay, so we can shift to the right by pi over 2, and we can adjust our period to be 1 pi. Okay, so we can go that way. Or remember, you can also say that whatever's inside those parentheses would go between 0 and 2 pi. Okay, we can go back to here or to here, either way. We can say that that would start between 0 and 2 pi and figure out what x values would give us that, and we can solve that. So we would add pi to each piece. and we would get pi less than or equal to 2x less than 3 pi, and then we divide everything by 2. And we get that our x values for one period now go between pi over 2 and 3 pi over 2, which is exactly what you'd have here. You shift to the right by pi over 2, and then when you add pi to that, it would end at 3 pi over 2. So whichever way you prefer to figure out your starting and stopping points, this is what we have. So we're going to start at pi over 2, and we're going to go pi from there. Okay, or you look at pi over 2 to 3 pi over 2. So this is where one period is going to lie. So one cosine picture is going to lie in here. And then remember, we also have to take the amplitude into consideration. We don't have a vertical shift. We just have to use the amplitude as 3 pi. So cosine normally starts up at 1. So this time it's going to start up at 3 instead. So we start at 3, we end at 3, and we know for cosine halfway, we're at our low point, so that's going to be at -3. And halfway between each of those, we're going to cross 0. Okay, so you should be able to see now one period of the cosine graph, and I'm going to dash this in because remember, this picture is not actually our graph. Okay, and then if you want, you can keep going. So every 2 notches, we're going to have a 0. So I can see it's going to continue like that. And down to 3. And I can continue back the other way as well. Every 2 notches, we have a 0. So that's going to come back down to here. We've got to have a low point between those two. And so on. Depending on what the directions say, they might say 0 to 2 pi, might say 1 period, might say over the full graph. Okay, so you can continue this on for as much as you want to. Okay, so there's our cosine graph. Okay, we started with our 1 period right here and then extended it on. But now what we want to do is we want to draw the secant graph. The secant graph. Okay, so anywhere that there was a 0 in the cosine graph, when we do the reciprocal, that's going to be undefined. So everywhere here that you see a 0 is going to become an asymptote. There we go. Okay, so every time we counted 2 notches every time to get a 0, now we're going to count 2 notches every time to get an asymptote. Now the original graph is dashed just to remind us that it's not actually part of the picture. Obviously they're not asymptotes. Okay, we're just dashing those because they're not part of the picture. Okay, and then remember, every time we have one of these bumps, that's going to flip and become one of the U-shaped pieces. So it looks like that. And that. Okay, so each one of these we flip like this. Okay, so the red graph is our secant graph, this one right here. The red graph is our secant graph. So the black line is what we use to be our guide. Okay, the black dashed line, that's our cosine graph, that's our guide. And then getting secant from that is just a matter of inverting everything. So if this was a cosecant graph, you'd want to do the sine graph that goes with it and invert everything from there.